Yeah, it's only on one place that your parents like their time.
Alright, for number 1, you had to find the domain of this. You can write this in set notation or interval notation. Your domain would start at 2, and it would keep going to infinity. So you could write it one of 2 ways. X is greater than or equal to 2, or you could start at 2 and go to either of those is fine.
I put it in the second way.
That's fine. For number 2, which points are solutions? The best way to see that is to graph them and see does it fall in this shaded area or not. So negative 2, 4, 0, 3, and 5, 1. Of these points, which ones are solutions? Negative 2, 4 definitely is. And that's the only one.
I want to be done.
If it was a solid line. Oh, okay.
See, I think there's some.
Number 3, we needed to distribute and combine the terms. So this would give us negative 12x minus 6, negative 2x plus 6, plus 15x minus 20. You add up all your x's, you'd have negative 14 plus 15, which would give us this 1x. And then negative 6 plus 6 cancel, just leaving negative 20. Questions on those 3? For number 4, is this a question? Yes. This is a vertical line test, so that one is a function. And then for number 5, the equation of the line, if these 2 points are on the line, you could plot these 2 points and then go back and find your slope and y-intercept from this. So right here, this has a slope of 2 over 1. So if I go backwards, down 2 to the left 1, down 2 to the left 1, my y-intercept would be at negative 4. So our equation would be y equals 2x minus 4.
I have a question.
Yes.
How did you just graph the 2?
Graph the 2, find the slope, and then go backwards to find your y-intercept.
Okay. Brilliant.
Other questions on those 2?
Check.
Alright. So, to recap things that we've talked about in this unit already. We started factoring with GCF, finding the highest thing, number of variables we can divide out of things. Then we did difference of squares, where we end up with 2 factors, one is plus, one is minus, and we're basically taking the square root of numbers. Then we did a combination of both of those. And then the last thing we did, and those of you that weren't here, I think I do have those notes, but those of you that weren't here will have to look on Canvas to see those. But what we do today will be somewhat a mixture of that and something else.
I am a little confused on factors.
I'm like 10 minutes because I brought the wrong helmet to school and I have a game, so I have to like switch it out.
For you guys, yes.
Okay. So everyone should have these notes in front of them. So we are going to first learn how to factor by grouping, and then learn something else. So when we factor by grouping, we're going to have 4 terms. If we don't have 4 terms, we can't factor by grouping. And the very first thing we're going to do is kind of split this down the middle. Once you get into the hang of this, you don't actually have to split it down the middle. You can visualize that you split it down the middle. But when you do this, whatever the sign is in front of the third term goes with the second set of numbers or terms.
What?
Whatever this sign is
Yeah.
goes with the second set of terms.
Okay.
Then we're going to be looking for the GCF of both sets. So what do these 2 things have in common? X and how many X's? 2. So that means we can divide these both by x squared. And remember, when we're factoring out, we are dividing, but we're not actually getting rid of it. So we're going to put this GCF on the outside. And when we divide, we're putting what's left. So x to the third divided by x squared would be what?
X1.
Just 1x, or x to the first, either or. And 7x squared divided by x squared. 7. So it'd just be plus 7.
Why?
I got it.
Yes.
And then we're going to do the same thing for the last 2. What do these have in common? 2. And whatever this sign is, we're going to bring that down. So if we divide out 2 to both of these, what would that leave us with? X and then plus 7. Before we continue, what do you notice about this part?
They both have x equals 7.
Yeah.
And they're like the
On the inside, we can call that. So if they both have the same inside, then we can do the next part. If they don't have the same inside, something is wrong. And you have to go back and fix it. I mean, I think you're about to ask something.
I didn't think so.
Say that one more time. What's the what? How do we do this? We're subtracting the x.
Okay, what if we just like do 2 steps?
Lily, did you have a question?
I did not know. I'm just trying to figure this out.
Okay.
I'm really.
So once you're in this, once you have this, you're going to take what's on the outside, and you're going to put those together in parentheses.
Wait, what are you doing?
Taking the things on the outside and putting them together in parentheses. And then you're going to take the things that are inside and put them together in parentheses. Really, you're taking both of them and putting them in the same set of parentheses so you don't have to list it twice.
Yeah, isn't that where FOIL comes into play? Is this supposed to answer?
Wait, are we gonna put 2x squared?
Hold on. We are going to use FOIL to check ourselves. Peyton, what was your question?
Why isn't there 2x plus 7?
Since these are the same, this is just one factor. We wouldn't write it twice. Bella,
Is it always gonna be the same?
it should. Otherwise, it's wrong.
How'd you get that's
For which part?
What?
For which part?
Okay, so you have the 2 and you took them and you made a single parentheses. How did you get
We took the inside things and put them together, yes. But because they're the exact same thing, we're not gonna write it twice.
Okay.
First, outer, inner, last one, we multiply and distribute. We're gonna do that in a second.
Do we want to?
We're subtracting the extra. 3 minus 2 is 1. Okay. So this is our final answer. These are our factors. To check yourself, we can use. No. To check yourself, we can use FOIL. So we are going to multiply x squared times x, which would give us x to the third. X squared times 7.
7x.
2 times x,
2x.
and 2 times 7. So if you multiply this back out and what you get is the same thing we had originally, then you're good. Now, Olivia asked, is this necessary? I heard you, but hold on. Is this necessary? No. But you may want to do this just to make sure you're on the right track. Maybe not for every single question, but maybe you weren't sure about the factors and you just want to double check. And that's when I would double check. Hold on. Lily, what was your question?
So the 7x squared is because if there was 2, we put them into 1, right?
You're talking about right here.
Yeah.
X squared times 7 is 7x squared.
Oh. Thank you.
Hold on. What was your question?
So is step 3 the answer then?
Yes. So,
Can we just distribute in the calculator on like?
you can't distribute variables in a calculator, so no. What do you say? First, outer, inner, last. Alright, let's do some of these examples.
There's just a pure shock.
Starting with number 1. Split these down the middle. What do the first two have in common?
3x.
3x squared. Now, I'm not going to have space to write the division part, but you still can. I'm not doing that, but know that we're still doing that, even though I'm not writing that.
I have a question. What are we doing for like our what's our GCM? 30.
X squared.
Wait, so the GCF is the thing that's on the first number?
No. It's what they have in common.
Oh, okay.
Good luck.
So determine if splitting them up is the same as the first and the second. But if now writing on it's 5.
Grouping only works with this 4.
But
If we divide both of these by 3x squared, what will be left?
5.
5 for the second part, yes.
It's 3x 1 plus 5.
X plus
plus
5. And then what could we divide out of the second two?
2.
Negative 2. Bring that sign down. And if we divide out negative 2, what would be left?
X plus 5.
Wait, are you 5? That's important. If we didn't take out a negative, we'd have negative x and minus 5, which would tell us there's something wrong there. Our insides are the same, so that's going to be one of our factors, x plus 5. And then everything on the outside will be the second set of factors. It does not matter the order in which you write these factors.
I like this one. You good? So. Wait, what's the sign? Oh, there's this.
What questions do we have on that one? It doesn't matter if I put this one first or this one first.
Why?
What's 3 times 4?
The same thing.
What is 3 times 4? What is 4 times 3? Well, that's why it doesn't matter. Right, number 2.
Wait, where in the world did you get 4? Oh.
For number 2, split them down the middle. What do the first 2 have in common? 8x. Not 8, sorry. 4x. We divide them both by 4x. What's left? 2x plus 3. What could we divide out of the last 2? Y. Positive y. And what would be left? 2x plus 3. As you're doing this, you can almost assume what that second inside is going to be, but at the same time, don't assume what it's going to be. Make sure it actually works out.
Wait, but you said that it didn't work there, like whatever you work.
Right, that's why I said you can assume what it should be, but don't actually assume it, like actually still divide it to make sure it works. What happens if it doesn't work? Something's wrong. Because the inside should be the same. What would our 2 factors be? 4x plus y and 2x plus 3.
It's so hard.
On what?
Okay, so first
What?
things first. The 2x plus 2y. Now the 2xy. Let's do that 2.
I was not following. Say that again.
Okay, so 2xy plus 3y. And then now it's just plus y, then parentheses 2x.
We divided a y out of both of these.
Okay.
That's the GCF is y.
Okay.
And then you divide everything by 1.
We're down to number 4.
So why is that here?
Split the middle. What do the first 2 have in common?
X3.
X to the third.
Yeah, we did do this already.
Not here. You may have previously in another class, but not here.
No, we did this last time. We did GCF and we did the under.
Before spring break.
Yes,
We did something else. For this one, the number of x's these have in common is 3. If we divide both by x to the third, what's left? X plus 4. What do the second 2 have in common? 2, positive 2. And what would be left?
X plus 4.
X plus 4.
No.
So what would our 2 factors be?
X plus
X cubed plus 2 and x plus 4. Jumping to number 6. What do the first 2 have in common?
X squared.
X squared. We divide out x squared, what's left?
Y.
Y plus 3. What do the last 2 have in common?
7.
Negative
Negative
Y.
y and y. Yes.
What happens if there's a minus sign?
We're bringing this one down.
Yo, we're moving really fast.
In the middle. Right here?
Yeah.
Then this would be mine. So negative 7y, if we divide both of those by negative 7y, what's left? Y plus 3. So we're divided by negative. What would our two factors be?
X squared minus 7y.
X squared minus 7y and y plus 3. After you finish this one, turn the page over to the back.
Okay.
We're going to do number 10 and number 11. So with number 10, what is our GCF for the first two? A squared. A squared. What would be left if we divide out a squared?
A plus C.
C. And then what is the GCF of the second two? B. On the back of, should be on the back of the same page.
I don't see it. This one doesn't matter. I rewrote it. Is it not there?
No.
Yes, it is.
No.
Some of you have it,
Why
some of
would
you
you
don't.
find a third? A to the third plus a to the squared. Yeah. Find that. I have that. Easy.
Who does not have that?
No. Okay, so it's literally I like
On number 11, actually, you can please start. What was our GCF for the second two?
oh for
B. B.
I didn't get the paper.
Oh, you needed that too. I don't know if I have that hold on.
Do I have to go to the coffee room?
What's divided by
I don't know. I thought it was also
What's the GCF of negative 4?
So is it me or is that holy smokes, what are you doing? Are we dividing it by B? Or you want to? What are you doing? No. Okay, I'm dividing it by where do you buy what? I know, I think I did it. Maybe that's another story.
What are your two factors? Yes. You have a squared plus b, and then a plus b.
Basically,
Hold on. Guys, please stop talking. You're dividing on a B. For 11, what is the GCF for the first two?
RS.
4RS. If we divide out 4RS, what's left?
R plus minus 2.
and then the second one is 2, but it's like positive.
No, it's -3.
The GCF is -3. And that would give us
R
-2. So our two factors would be
4RS minus 3 and
R minus 2.
So now, keep this method in mind because we're going to move on to the next page and we're going to use this, but more to it.
oh my.
I got minus 2.
That's not what you think.
So before we actually try this, I'm going to talk through the instructions and then we'll actually do the example. So the first thing, we're going to look and see, does it have a GCF? It could not. The GCF could just be 1. If that is the case, we won't really do anything. Then, before we talked about factoring trinomials, when this value was just 1, so we didn't have to do this part. When that value is not 1, you have to do it this way. You take this value and multiply them together. Whatever that number is, we look for factors that multiply to get that, but then add to be b. So that part is similar to what we did last time. And then after we find that, we're going to rewrite that so that there's 4 terms, and then grouping comes back into play. So again, those were just the directions we're going to actually do this, yes.
I have a question. You don't like me because none of my packets have any of these pages. Sorry. And you gave me 2 packets.
She said she tried to make some stiff statement. Let's go fishing.
I don't even want to eat outside. It even hurt.
So I go make the copy. You fold paper in the machine and
What am I gonna give a task to them? My dad is gonna drop
After we finish these 4, if he still has it, then I'll write you.
For number 8 on the front, what was the
for negative X minus.
Hold on.
Did you get the right package?
Alright, let me get everyone's attention right now. We're going to go through these first 4 examples. For number 1, does this have a GCF?
1.
It
Yes,
does. It's
the
1.
X. The X.
And
No, it doesn't. Where's the X on the
3?
3?
You don't need the X on 3.
Yes, you do. They all have to have an X.
Sure.
Yes, I'm sure I'm smart.
Yes. So for this, GCF is 1, but that wouldn't change anything. But it is good practice to know what the
It's
GCF
still
is.
1. But it doesn't change anything, so technically.
But it doesn't matter, it's still one.
It's fine, we can say that, but the GCF is still 1.
You don't write it though.
We are going to write it.
Well, to solve it.
Okay. The next step, we're going to take the first and the last numbers, the 2 and the 3, and multiply them together.
Wait, what about the x squared?
We're only doing the numbers.
But that's the number because it's squared.
The coefficient
Oh my
and the constant. Not the exponent, but the variable. To organize these numbers, I'm going to draw this x off to the side.
We're doing that again. No, I actually like that. That makes sense. No, it makes sense. You did.
Wait, it's 1.5 actually.
2 times 3 is what? 6. So we're looking for two numbers that multiply to be 6, but add to be this middle number 5.
What in the?
2 and 3.
Hold on.
2 and 3 would work.
Yeah, 2 and 3.
Yeah, 2 and 3.
I'm confused. I wasn't saying that was wrong. I was saying that would work, and I was giving everyone a chance. Write it out.
Yeah, see?
We did-
have the multiplication.
We did part of this last time, but this is a little different.
You have to have the numbers.
Okay. So last time we did this, we went straight into the factors. That's not what we're doing today. Once you have this, we're going to rewrite this. The first and the last term are going to stay the same, x squared. But we're going to use those two factors we found and put them in place of our middle term. So it was 5x, 2 plus 3 gives us 5. So we're going to put those instead of 5x, so we have 4 terms instead of 3.
But it's still only 5.
Yes, we're not going to actually combine the like terms though.
What about the end?
What does that mean?
And we're going to include the x since this had x. So this will look like 2x squared plus 2x. I'm going to do this in this letter. Plus 3x plus 3. We're rewriting it so it now has 4 terms.
Wait, but they still don't have a GCF.
But because it has 4 terms, now we can do grouping, what we were just doing before.
Oh, okay.
So
No,
you're just
we are not going to combine the like terms here.
So you're just splitting the middle term up?
Yes.
Wait, where did the 6 and the where did the 6 and the
2 times 3 gives us 6. And 5 was the middle number. So it will take some time, but we have to practice to get better. So the GCF of the first two is what? 2x.
Yeah.
And if we divide up 2x, what's left?
2x plus x. X plus x.
X plus 2. I'm sorry, x plus 1, yeah. What is the GCF of the second two?
3.
Positive 3. And what would be left?
X.
Plus 1. So then what would our two factors be?
2x.
Does it matter which one you write first, like 2x or 3x?
So for this, if you wrote it as 3x and then 2x, you would still get the same answer, even if you did it a different way. So I'm going to show that really fast. You do not need to write this, but you can if you so choose. So if we did it this way and wrote it the opposite way, still splitting the middle, what would the GCF of these two be?
2x.
Not 2x, just x. Which would leave us with 2x plus 3. The same problem a different way. That's the answer. What would the GCF of the last two be?
X. No.
1. So even though when we write our factors, we would get the same things even though they're switched. So it doesn't matter the order you write it.
Why do we have to split them then?
I don't know.
Okay.
Bella.
Where did the 3 and the 2 and the X?
Two numbers that multiply to be 6 but add to be 5. Or what?
I'm sorry.
Two numbers that multiply to be 6 but add to be 5.
Oh.
That's where we got the 2 and the 3. Other questions on example 1 before we move on to example 2? Does example 2 have a GCF? GCF is 1. So we are now looking for two numbers that multiply to be 5 times 6, 30, and add to be negative 17 or subtract.
So ask 5 times 6 back and then add
So 30. So it has to multiply to be 30, but add or subtract to be 17.
negative 15.
Negative 17. Negative 15 and negative 2 would work.
Oh yeah.
So then your first and your last terms would stay the same. As you start to get the hang of this, you may want 15 to go next to 5 since you know they both can be divided by 5, but again, the order doesn't matter. Oh. So whatever the variable is, make sure it stays the same, otherwise you will have different variables and not be able to take out a DCF correctly. What is the DCF of the first two? 5M, which would leave us with
Minus.
Minus. I said plus negative 3, but minus 3.
minus 3. And then what are the GCF of these two beings?
Negative 2.
Which would leave us with
M.
minus 3.
Oh my god.
And then our two factors would be
5
wait, that doesn't work. It should just be M minus 3. So 5M minus 2 and M minus 3. Don't put plus minus. Other questions on that one? What is the GCF for example 3? 1. So we are looking for two numbers that multiply to be, say it again, negative 24, and add to be negative 5. Negative 8 and positive 3.
What happened? Just like,
So then we would rewrite this.
her whole body was filming. Yeah. She just
6y squared minus 8y plus 3y minus 4.
Okay.
What would our GCF of the first two be? 2y, which would leave us with
3y minus 4.
minus 4. What would the GCF of the last two be? No. You can always divide out something, even if it's 1.
Plus 1.
So what would our two factors be?
I cannot be like, I don't know what I'm confused about. That's confusing.
Example 4. What is the GCF?
1.
1. And then we're looking for two numbers that multiply to be
60.
negative 60. Language, and then add to be 11.
No, we didn't. It's not 30.
Okay, not that.
It's 15 and 4. I mean,
Yes, but what do we have to be negative?
negative 4.
Negative 4, positive 15.
Negative 15.
12c squared minus 4c plus 15c minus 5. What would the GCF of the first two be?
4.
4c. What would be left? 3c minus 1. What would the GCF of the second two be? Plus 5, which would leave us with 3c minus 1.
Would it be negative 30?
No. Negative 60 won't be there. The 11 was already there. So we're going to do 11 and split it.
Let me finish this and I'll write your back. Sorry.
What are our two factors?
4c plus 5 and 3c minus 1. This is easy. Good.
We're going to do 3 more examples on the back.
Is this in the office?
Yeah. So you do 12 times 5. That gives you negative 6. Or 4 times 2.
But the way you remember is the way is 6 times 4. The top. Okay? But it has to be 5.
Okay, so this gives. Yeah.
And then, so there's 2 equals 5, it's 24, and then my negative 8, that's 3.
We're going to start with number 10 on the back.
Yeah. I was confused how you got this.
What did you say? No. Someone else did that. For number 10, does this have a GCF?
2?
Wait, where are we?
2 words on the back, but it's not the highest.
The second one.
Oh, that's right. Got it.
4.
4. Now, I do want to show you this. You can't do this on your calculator, but you can do this in Desmos. So when you're practicing, if you want to use this, you can use this. In Desmos, in the graphing calculator, if you go into your keyboard, go into your functions, scroll all the way down to number theory, look for GCD, which is greatest common divisor, factor, divisor, we're dividing out the factor, those are the same thing. And put in all the numbers. What were the coefficients of those numbers?
52 and 24.
Doesn't matter if they're positive or negative unless the first one is negative, and it will tell you what that GCF, GCD is.
I like that.
I don't think we have any.
No, you do not. So once you figure that out, we're going to divide out that GCF. So if we divide 4 out of everything, what would be left?
Minus 13. Minus 6.
So now we have smaller numbers to work with. I am going to show this example again if we didn't see the GCF, but we'll do that here in a second. So now when we do this, we're going to bring this 4 all the way down. We're just going to keep dragging it along. So now we are looking for two numbers that multiply to be 5 times negative 6, so negative 30, and add to be negative 13.
What's the question? Negative 15.
Yes, that one here. Multiply to be negative 13, I'm sorry, multiply to be negative 30, add to be negative 13. Sometimes you may think of two numbers that you think would work, but they won't actually. There are only two numbers that will work. So if you did like 10 and 3, that wouldn't work because they would both have to be negative.
Yeah. 5 and 8.
5 and 8 don't equal 30.
Okay. Okay.
So negative 15 and positive 2. So then we are going to do the same process, but just bring the 4 down. We'd have 5n squared minus 15n plus 2n minus 6. And then the GCF of the first two inside, I'm not worried about the 4 on the outside, would be what? 5n.
Whoa.
Wait, did you make those parentheses?
Yes, I made double those. If we divide out 5n, what's left?
2.
N minus
Oh, that's 3.
and then GCF of the second two.
2.
And if we divide that out, what's left?
And minus 3.
So now when we write our factors, we would have 3 things. The 4 would be on the outside.
So we multiply that now.
It would just be left on the outside. And what would the other two factors be?
5n plus 2.
So when you go to check things like this, you have different options. You can either multiply the 4 times everything here and then multiply that to everything. You can multiply the 4 to the second set of numbers and then multiply that to everything. Or you can multiply these two together and then multiply 4 to everything. We just factored it out, but we can't get rid of it completely. It just has to get brought along.
But then the answer of the 4 and also
Otherwise, it would change the answer completely.
Okay, so obviously this is like easier. But if you didn't do like the first one, this common factor, and you just did all the big numbers, you're still doing the same thing.
Yes, we're about to do that.
That's less steps.
So you don't have to write this down, but you can if you want to. If you did want to write this down, write it down in the small space at the bottom. 20n squared minus 15 minus 4. So this would be if you didn't see there was a GCF. Now, anytime you do this and you don't do a GCF, you're going to end up with really big numbers, so be expecting that.
But the answer should be wrong. Like, what would still be right even if you didn't find the greatest common factor?
Yes, as long as you find it eventually. So just like when we did GCF, if you don't find the highest and you find it later, that still works. So 20 times negative 24 is what?
Oh, sure.
Negative 480. So we're looking for two numbers that multiply to be negative 480 and add or subtract to be negative 52.
I don't even know. I don't even know what to give you that.
Same. So for this, you would start with the easiest one, 1 in itself. Because I don't know the factors of 480 either. And then we'll just keep going. So it's even, so it has to be divided by 2. Can it be divided by 3? By 4? By 5?
96.
By 6? 6 and 80. And not there yet. By 7? By 8? And it has to be negative. And if you do negative 60 and positive 8, that works. Sometimes you have to do more depending on how big the number is, but you would just make a tree, make a paper factor tree, and then do the same process. So 20n squared minus 60n plus 8n minus 24. GCF of the first two,
20n.
20n, which would leave us with
Minus 30.
and
Minus 3.
And then GCF of the second two, which would leave us with and minus 3. So then our factors would be now when you look at both of these factors, one of them is not prime. That would tell you you need to still factor out a GCF. What could we divide it over to? 4. Which would leave us with you would get the same answer either way. It's your preference which way you want to use.
Are we gonna find a price?
Probably not today, but next class, yeah.
Yes, I can.
I just messed up how. Okay.
I know how to use a commercial. Like, our students teacher. Every time. I don't know what it is. What's that? I forgot.
I want to get at least 11 done. If we can get 12 done today, then you'll have more time to practice next class. But if we can't, then we'll start next class the next class. Number 11. What did you see? 5. If we divide 5 out of everything, what's left? Okay, squared plus
20? No.
75, that would be
I'm close. What was it? 15.
15.
Okay.
and 7. And then we're looking for two numbers that multiply to be
15 or no? 14.
14.
Okay.
The closer these numbers are, one of your factors is going to be 1.
So it's 1 and
1 and something 14.
One.
Wait, Are you supposed to multiply? Oh, 2.
We have 5 2k squared plus, you can put 1 or 14k, first doesn't matter. What would the GCF of the first two be? Depending on how you wrote it. In mine, it would be 2k. If you switched it, it would just be k. Leaving what? K plus 7. What would the GCF of the second two be? 1. Leaving, k plus 7. So our final factors would be what? We're missing something? 5 at the beginning. Alright. Really quickly, let's do 12, so you'll have more time to practice next class. GCF of 12. 2. We divided everything out, or 2 out of everything was left. Plus x minus 1. And then we're looking for 2 numbers that multiply to be you have to add to be 1, but multiply to be 12. -6. What 2 numbers would multiply to be -6, but add to be 1? Two and the other way around.
-3.
No. You guys just said the same thing, but opposite. -2 and +3. Sorry. We have 6x squared minus 2 minus 1. And then until we're finished. Until we're finished. What would the GCF of these two be? What's leaving x minus what? Or 3x minus what? 1. And the GCF of the last two?
I want to have smart people.
I want to be smart.
1.
I'm just not smart.
Leaving 3x minus 1. What are our final factors?
2 parentheses 2x plus 1 parentheses
Eventually, someday.
I want you to circle these problems. These are going to be the ones that you're practicing next class. Starting with grouping. Numbers 3, 5, and 12. Make sure you're circling these numbers 3, 5, and 12 on grouping. 3, 5, and 12 on grouping, and then factoring trinomials numbers 1, 2, 7, 8, and then 13 through 15. So 1, 2, 7, 8, 13 through 15. Is that it? Yeah, you can do more if you want. That's for you.
This is my.
Did you? Yeah. You